Thanks to the organizer for allowing me to be here, for giving a talk, an empirical study that is it has not often been seen at this conference. And my thanks is truly felt also because by coming here in Beijing, this is my first opportunity I have to be in China, and from next week I will be based at the Kunming Institute of Zoology. So it's been a very exciting experience so far to experience China for the first time here at the conference, and for the next 2 years I will be busy here in China with my postdoc. And with my presentation I will show you instead what part of my results coming from my PhD thesis that was done in Strasbourg and at the same time looking at monkeys in South Africa. So I will try to show you an implementation of a game theoretical model to study cooperation in vervet monkeys. So I will introduce this experiment in a quite common way as biologists look at the problem of cooperation. So it is quite understandable why individuals would cooperate if they are kin, if they are related, because they would advantage other individuals who share genes with the initiator of cooperation. So this was the kin selection theory by Hamilton in the 60s. And so it was quite normal to understand why cooperation can evolve in these individuals. Later on in the 70s, Trivers gave a very good contribution to understand why cooperation is still found in individuals that are not related. And it makes sense to cooperate with other individuals when there is a sort of expectancy in the future that your cooperation effort will be exchanged back. And later on, Axelrod and Hamilton gave another extremely nice contribution to the problem of evolution of cooperation by looking at game theory and the iterated prisoner dilemma game, which exactly focus on the iteration of the cooperative acts. So it looks really at the reciprocation that partners expect in the future. I will define cooperation in a very standard way in this study. So it is a behavior which provides a benefit to another individual and which is selected for because of its beneficial effect on the recipient. And specifically with the vervet monkeys, by cooperation I mean food sharing, and we will see this in particular later when I explain my experimental setup. And why do we study monkeys for this? Well, I'm talking mostly with theoreticians, but it's very obvious why, so I will not go into details for that. But let's put it generally, just because they are a very appropriate group of, they are very appropriate species, especially vervet monkeys, to bridge the gap between humans and other animals. So evolution of cooperation, it is key to study evolution of cooperation in primates, especially vervet monkeys, because you know, in many primate species, the social system can vary. They can belong to relatively more egalitarian species, or other primates can belong to relatively more despotic species. And vervet monkeys are believed to stand in the range of primates that they are despotic, but not despotic to too much of an extreme, and they are not certainly egalitarian. So they do represent quite well our human way of behaving, if we can really say so. And for me, it will be very interesting to later on during my postdoc to see how humans cooperate differently here in China, in the Oriental world, rather than the Western world, since most of these studies are done in the Western world. So this is when I will be studying cooperation in humans during my postdoc here in Kunming. And another note on vervet monkeys, they are a female philopatric species, so differently from what it is found commonly. The alpha, the dominant individuals are mostly females, and it is the males that have to migrate from group to group to improve the mixing of genes within the same territory. So the aim of this experiment was to trigger cooperative behavior and assess any changes in the social structure. And specifically, I was interested in looking at partner choice. So the key question in this experiment is, do preferred companions outside the experiment, do these companions can predict cooperation partners during food sharing? And I will try to answer to this question now. This was the setup in the field. So you see a group of monkeys. I worked on 3 different groups of monkeys in the field. This is the diagram of one. And so you have so you have, okay, let's go back. Yeah, you have a group of monkeys, several individuals, and I gave them these boxes that contain food, all right? So these are the feeders. And I divided the group into 2 classes. A smaller class that comprised of 2 individuals that were always able to access food to a black box. So the box was colored in black. And the remaining of the group was able to access food to the boxes that were colored white. Okay? So this was the training phase. During the cooperation phase, the 2 feeders, one black and one white, were put adjacent in space. And at this point in time, the monkeys were able to access food only if they were coming from both classes, the smaller class and the larger class, and they had to be in at least 2 partners in order to be able to access food. So you had to have at least 1 monkey coming from the smaller class and 1 monkey coming from the larger class. The cooperation I looked at was not only dyadic, could be also triadic, polyadic in general. So you could have 2 monkeys coming from the smaller class and several monkeys coming from the larger class. No matter the amount of monkeys, they had to be at least in 2, so this is what we call cooperation in this case. And they really had to belong from the 2 classes. So the monkeys coming from the smaller class were always the same individuals. Why did I divide the monkeys into 2 classes? This was interesting for partner choice because by doing so, in the smaller class, I always chose at the beginning 2 monkeys that had to be at least 1 male and 1 female, 1 dominant individual and 1 subordinate individual. and one adult and one juvenile. All right. So by looking at partner choice, I was interested in looking at partner choice. So by having the smaller class represented of individuals with all possible combinations of male, females, adult, juveniles, and dominants and subordinates, I could test whether the partner matching was working. I could have many combinations of this scenario, all right? So this was only one group. I had other two groups, 3 groups in total. So the possible partner matching was very high in number, okay? So I could have had many combinations. Did I explain it correctly? Are there any questions? Is this not clear? Is it? No? Okay, I go on. But please stop me and we can go back to the setup if it's not clear, okay? I will show you a video to give you a better idea of how it worked in the field. So, to try and have really a realistic type of cooperation, this game was repeated in time, so the monkeys could access food several times per day, during many days. And it was a field study, of course, so these monkeys were wild monkeys. They were not in the laboratory or in the zoo. They were from a nature reserve in South Africa. It took quite a few months to get the monkeys habituated to me and other researchers while we were studying them. And another factor is that I was trying to study cooperation beyond diets. So not only 2 individuals could access these feeders, you could have had cooperation coming from more monkeys at the same time. And cooperation was asymmetrical. So this means that you had one class that was smaller and another class that was larger. As it often is the case, you do not have availability of many partners at the same time when you cooperate in the real world. And so this was leading towards this matching market design that for which Alvin Rod in 2012 was co-recipient of a Nobel Prize for Economics. And basically the matching market looks at usually the best examples are for students that need to be allocated to the best colleges, or the marriage dilemma, that is how husband can find the best wives for matching during weddings. And Alvin Roth won the prize, especially for his contribution in medicine, for lately understanding how kidney donors can be found, the best matching for partners. So this is a picture that shows you how the setup was in the field. So you have monkeys standing in front of these boxes that were providing food. I was also video recording part of this data. And now I will show you a video of these experiments. So you can see on the left side, the monkey there is one monkey coming from the smaller class. So it's standing in front of the black feeder, and it's just getting some remaining food from a previous trial. So now another partner comes, and he belongs to the larger class. And now the feeders are activated so that they can provide food to the cooperators now. So they are feeding. In the other case here, there is only one monkey, so cooperation doesn't take place and the monkey cannot access food. In this case, a third monkey came to the right group, so they will be able to carry on feeding, and in this case, my cooperation, food sharing, will be amongst 3 partners, not anymore 2 partners. Okay? The individuals had.
Just one question. How did they want to know individuals they belong?
Yeah, well, that was this training phase.
So you train to the color of the feeder?
Yeah, exactly. So during the training phase, the feeders were not joined.
But the monkey was happy feeding from the white one, and then you said that it's from the black one.
Yeah, well, that's right. This is technical lesson, okay? So the boxes, I had some control over the boxes. I had a control remote, and I could lock or unlock a button that was on the top of the feeder, and only by pressing the button the monkeys could access the food. So when I saw that it was not the right monkey to the right feeder, the button would be locked, and the food would not be provided to the individuals, right? Yeah, it cannot be seen well here, but on top of these feeders, there are buttons. And by a remote control, I could operate them. And by the training, during the training phase, was always the same monkeys that got accustomed, got used to feeding from the same feeders. So as you could see in this example, when the right monkey goes to the black feeders, it's because by time the monkey understood that it could access only the right feeder, okay, on the right side. Usually it would keep the black feeder on the left and the white feeder on the right to help them. So the data I'm showing you are proximity measures of monkeys feeding from their natural resources, not their food. This gives me a baseline of the monkeys feeding, not during a cooperation phase, okay? And the real cooperation when the monkeys are feeding from the feeders. So they are forced to be in at least 2 or more partners in close distance in space, and they have to access food. I analyzed most of this data with network analysis. So here you see the social differentiation index that tells you whether in a group the individuals are connecting to each other, okay, and the way they do it. So when this index is low, you have a group of individuals that are able to connect to all the other individuals. Whereas when this index goes up, the network is not homogeneous, it becomes heterogeneous, and only a few individuals have the opportunity to join with other few individuals. So my expectations were those that during cooperation, if there was a partner choice, their network would become more heterogeneous in time. So here you have the 3 conditions, 2 baseline conditions and the cooperation condition during the food sharing. And what I found in the 3 groups was actually that, yes, the monkey appeared to select other specific partners to cooperate with. So this was a first indication that there was a partner choice effect taking place during this cooperation experiment. And later on, to better understand which partners was selecting which other partners in the group, I constructed cladograms that could tell you which monkeys preferred other specific partners for their food sharing tasks. Okay, so you will you will later see three graphs for the three groups and for what happened. And here at the bottom you have the individuals belonging to the group, and the individuals circled in black are the two individuals coming from the smaller class. Okay. So this individual number 9, for instance, had the opportunity, preferred to cooperate with individual number 1 most of the time, and sometimes also with individual number 3. Whereas individual number 9 didn't cooperate with the other individuals on the right, who, on the other hand, cooperated with individual number 4, the other individual belonging to the smaller class. Okay? Remember, in the smaller class, I always had only 2 individuals. And a bit similar to the way of the presentation of yesterday by Uta, you can see that in the real world, monkeys have phenotypes. They have tags, of course. So when you assign to the individual their specific sex, age, rank, or kinship, you can actually understand whether, for instance, a male prefers cooperating with other males, or on the other hand, a female prefers cooperating with a male or other females. So by looking at partner choice, I was interested to see whether males prefer cooperating with other males, or females with other females, or instead they employed a mixed sex strategy. In the same way, I was interested to see whether adults prefer cooperating with other adults, or on the other hand, maybe they prefer cooperating with other juveniles. Looking at kinship, I was interested to see whether same family members prefer cooperating with other family members of the same family, or instead kinship didn't play a role. And the dominance, again, whether dominant individuals prefer cooperating with other dominant individuals, or perhaps dominant with subordinates. By pulling the data of the three groups together, I could, by mental test, see whether one of these phenotypes was playing a role in their partner choice. And the only phenotype that played a role was rank. That is, dominance selected other dominant individuals to cooperate with, and subordinates preferred other subordinates to cooperate with. There was no mixed strategy. That is, I didn't see subordinates cooperating with dominants. And I didn't either see a preferred pattern of cooperation for sex, age, or kinship. For kinship, this is rather interesting because kinship theory would predict that it's same family members that prefer to cooperate among each other. But in this study, no, I couldn't see this. It was dominance that mostly played an effect for their partner choice. So here again, you have the same data for cooperation that are plotted against the data for when the monkeys were foraging from their natural food, but not during the cooperation experiment. And you can see that there is a pattern only in the cooperation experiments, and it appears to be random. Whereas when foraging from the natural food, the monkeys didn't seem to prefer any other specific partner. Or perhaps they did have their preferred partners. But on average, in the three groups, the one choice didn't play a main role. Okay? So, with this experiment, I was able to prove that wild monkeys are able to cooperate in this specific setup of feeders. It was not that easy. It took a couple of months to get the monkeys used to the presence chose in the field in the first place to get them used to the presence of these feeders, and then it was rather easy to find the right food to give them that they would have liked. But once again, I didn't just give them any type of food. Since I was studying wild monkeys, I was taking good care of not having an impact on their natural foraging regime. So I preferred a low-caloric food to give them to them. And from this experiment, I could see that there was an increase in the variation of the social systems, and they became, these social networks became more heterogeneous during cooperation. This was a proof that there was a partner choice taking place, and the rule was following the social rank. That is, dominants preferred to cooperate with other dominants, and subordinates prefer to cooperate with other subordinates. So the subjects seem to limit their partner choice, and it seems like I was moving to witness a relatively more egalitarian network, and during cooperation, this network moved and segregate into a more despotic one, and not a nepotistic one. The nepotistic would be the one where same family members cooperated together. But in my case, it looked like the monkeys preferred monkeys coming from the same social class to cooperate with, which is rather interesting if we try to compare it to how humans cooperate. Yes, we first cooperate with our same family members, but most of the time we tend to cooperate with or to have friends coming from the same social class. So it's rather interesting to see how this seems to work also with these primate species. And just last year, a model came out by Robin Dunbar's group from Oxford, and Thomas David Barrett was able to prove something rather similar, just with agents that were assigned to a rank, to a power. So the agents had a certain weight, and at the beginning in the network, there was no specific partner, but later on, during several steps of the game that went on, in his paper, he was able to show that there was the emergence of social elites. And if you are interested, you can read the paper to see what were the requirements for this game to work. And in a similar way, he was able to show that it looked like individuals that could be called sort of dominants, clumped together, and subordinates clumped together on the other side. In a very similar way as I was able to show in the real world with monkeys. So that's it. I need to thank my supervisor, Ronald North from Strasbourg, the nature reserve that hosted me, some economic supplies from salmon boats, and the genetics that was done by collecting fecal samples and then analyzing the urine. And I thank you for your attention.
Thank you, Riccardo. So, questions? Okay, I have a question. So, I just wonder, for example, if the monkeys want to get some food, but there are some blocked, and they need to, only one monkey cannot get the food, but there is a threshold. If maybe in some situation, monkeys have to need the partners. There is no partner choice, right?
So the experiment was divided into phases. The training phase during when single monkeys could access food.
Okay.
And but during the cooperation phase, the rule was that you had to have at least two monkeys having access to food at the same time. So this is what I call cooperation and food sharing.
Okay.
And the data that I presented here are those coming from the cooperation phase. So the rule was that you had to have at least 2 monkeys for the feeders to work.
Okay. Thank you for the explanation. Other questions?
Thank you for a very nice talk and for a change, some empirical data. I was wondering, because you had this striking significance of rank, I was wondering, did you try to move the boxes apart? Because I could imagine that if they're so close, that the individuals would just try to avoid fights. And so if the boxes were a bit further apart, then you would, maybe rank would not play such an important role.
Yeah, that is a very interesting point. Yeah, you could say whether there is a total food sharing in primates. That is the first step. I believe there is, and this is the reason why they are social species. And it is true that by putting the feeders so close in space, as in this case, the monkeys had to overcome a certain fear or territory, space need for getting access to food. I didn't try to move the feeders apart, even though at first I gradually joined the feeders more closely in space, day by day, to get them used to having partners right one next to another one. But I didn't do it after, as a postdoc study, let's say, to see if the dominance could change. That is a very good point, yeah. Something that could be implemented. Even though I wouldn't be sure whether it would be easier for same monkeys belonging to the same dominance, whether it is easier for them to fight with monkeys coming from the same rank or rather from different rank, right? Would it be easier for a dominance to fight against a subordinate? Yes, for sure. But it is more difficult for a dominant to fight with another dominant. So
I was more thinking that if there's, let's say, if at the black box there's a subordinate, then that this guy would run away when the dominant individual approaches.
yeah.
Or vice versa.
Yeah, that's true. What I did, having 3 groups, I chose the rank of each individual belonging to the smaller class in a different way, in the 3 groups. So you do not have only, I show you, by talking about dominance and subordinate individuals, you do not have only dominance and subordinates. Of course, they do belong all to different dominant ranks. And as you can see here, I assigned rank to the individuals in a continuous way, all right? So the negative values are subordinates, and the positive values are dominants. So you can tell that individual number 1 was the alpha male in this case, and in another group, the monkeys belonging to the smaller classes would have a different rank, and I would choose them with a different rank just for this purpose.
Thank you very much for interesting talk on experiment and your discussion. And I'm not familiar with such a study of experiments. And could you tell me something? Actually, such cooperation among 3 or 4 monkeys observable in wild monkey life?
Yeah, they were wild monkeys.
I mean, so which means this is not first time for monkey, right?
It's not the first time for them to cooperate in general, or for doing this experiment. What do you mean?
I mean I wonder if this experiment is something learning something new for monkey, or actually real reflection, realization of wildlife experience.
So if I understand your question correctly, food sharing for sure is an example of cooperation, and you can say that in the primate world they wouldn't sit around the table as we do, as we share food. They would range around the trees, and the social group as such is together not only for defense from predators, because it's easier to be in a group if you need to defend from predators, but it's also because for looking for food. It's easier if you live in a social group to look for food and search food, especially in Africa in the seasons when the food can be really scarce. So food sharing it is a good example of cooperation. It is true that in the case of this experiment, I sort of made it extreme. It happens very rarely to have monkeys sitting one next to another and sharing food from natural resources, from fruit, from berries, from trees. And usually you would see it from mothers and siblings. But other individuals is more difficult, really, to have one monkey sitting next to another one. But they did overcome that after a certain number of days of training phase. And it was, for these monkeys, it was not the first time that they did this type of experiments. They had done similar experiments a few years before, but they had been habituated to researchers only for 3 years before this study took place.
Okay. Let's thank Riccardo again.